Welcome students and general seekers of truth, and welcome to the introductory video into the world of solids of revolution, and in general solids that are formed that can be calculated using integrals. In other words, how do we use the integral in order to calculate a volume? Okay, so let me give you an example. Let's say we start out with this function here, 0.5 e to the x, very basic exponential function. It looks like this. And I'm just going to graph it between x equals negative 2.3 and x equals 2.7. And over here I have kind of a 3D rendering of this. Now, let's say we take this curve and spin it around the y-axis. Okay, so we're going to take this blue curve right here and rotate it around the y-axis. What would that look like? Well, over here in the 3D view, we can see just that. So if I just take this and spin it lots and lots of times, let's spin it, have even more lengths there, and you see that we end up with like sort of a cup or a wine glass, I'm not sure, or whatever the name of this thing is. And you can see that we have with some help here, I can show you what the three-dimensional view of it. Okay, you can see that there's a base to it, and then it has this point here, and then there's the actual cup or the actual vessel itself. So one of the questions that we're going to deal with is, what is the volume of this? Okay, what is the volume of this vessel? And it's not entirely obvious from geometric formulas or geometric techniques, but using the integral we are going to be able to find the the volume of this particular object. And in other words, how much liquid can it hold? Okay, so that's one idea. Now I want to point your attention to another idea. Well, this time we don't just rotate it around the y-axis. We could also rotate it around the x-axis. So here I have another function, 0.5 x cubed minus 2x squared, and I'm going to rotate it this time around the x-axis. So imagine spinning this around this horizontal line right here. So it's kind of hard to imagine, but with a little bit of technology, I can show you what this thing is going to look like, and you can see now I have kind of a funny or a weird shaped vase. Okay, and so the question that we will ask, and it's basically the same question, what is the volume of this object? We could also ask and answer another type of question, which is, what's the surface area? So in order to make this object, how much material, what quantity of materials do I really need? Okay, so there you have it. Just two very basic ideas. Take a curve and spin it around an axis, and you're going to end up with a three-dimensional object, and we want to know the volume of that object. And then the other one is take a curve and spin it on the y-axis. So same thing, just rotate it 90 degrees and just spin it, and let's see what sort of object that makes, and then let's see if we can find the volume and the surface areas and answer some other questions about this. It's always fun to play around with these types of functions, so let's just do a little bit of it here. So what if we spin the square root function? Well, this is going to render for a minute here, so you can see I have some sort of like I don't know, very stout ice cream cone. Okay, and all of the geometric formulas don't really apply to this. They only apply to like a very special type of cone. This is certainly not that, and you can kind of see the blue line here as it as this function rotates through. Okay, so I'm going to end this video here, and then we're going to take a look at a second or maybe a third video where I talk about how to actually calculate the volumes of these types of objects. Okay. Well, there you have it. Introduction into solids and integrals, and how to use integrals to find solids. Thank you for watching. Be sure to watch the next video, and have